In this presentation, our objective is to define debts, compute the outstanding balance, and to solve problems amortization and sinking fund method. So now let's proceed to the first topic, which is the loan extinction. The methods to find time payment size are significantly dependent upon the debt extinction terms specified by contract. So loan extinction is like reaching the financial finish line. It's when you have successfully paid off the money you borrowed, including any interest. So in practical terms, it means you have fulfilled your payment commitments and the loan is officially closed. So for the next topic, we have the debt. Debt is something one party owes another, typically money. In a real-life situation, debt can arise when you take out a loan for a house, car, education, or even from using credit cards. It represents the amount you owe, and handling it involves making timely payments to the lender.
Outstanding balance. Outstanding balance is the amount of the loan at this time. One method to compute the outstanding balance is to get the present value of the remaining payments. This method is called prospective method. So, outstanding balance refers to the amount of money that remain unpaid or owing on an account or a bill after previous payment or transactions. Here are some methods for determining an outstanding loan balance. First, the prospective method. The prospective method is forward-looking, so it calculates the loan balance as the present value of all future payments to be made. So it involves using present information to make assumptions or forecasts about what might happen in the future. Next is the retrospective method. The retrospective method is backward-looking, so it calculates the loan balance as the accumulated value of the loan at the time of evaluation minus the accumulated value of all installments paid up to the time of evaluation. So it involves analyzing past financial data, transactions to evaluate the effectiveness of previous strategies to inform future decisions. Here are some examples for determining outstanding loan balance. But first, I'm gonna use prospective method in this example. Example number 1. Mrs. Morales borrowed some money from a bank that offers an interest rate of 20% compounded monthly. Her monthly amortization for 5 years is $11,122.22. So how much is the outstanding balance after 12 payments? So first I'm gonna list the given in this problem. So R, or her monthly amortization for 5 years, is 11,122.22. The interest rate is 12%. M is equals to 12 because it is compounded monthly. Time is 5 years. J, or J, is equals to R over M, or 12% over 12 is equals to 0.01. Then N is equals to M multiplied by T, that's why it is 60, minus the 12 or 12th payment, and then it is equals to 48. So this is the formula for prospective method. So B is equals to R times 1 minus 1 plus J to the power of negative times N minus K over J. So next step is to plug in. So B is equals to 11,122.22 times 1 minus 1 plus 0.01 to the power of negative times 60 minus 12, then over 0.01, and the result is 422,354.73 cents.
So here is the problem. A bank makes a loan of $10,000. The loan will be paid back after 10 years with yearly payments of $1,358.69 at the end of each year. The annual effective interest rate is 6%. Calculate the amount of the loan left right after the fourth loan payment using the prospective and retrospective method. So first, let us know what are the given. P for principal amount, it is $10,000. R for yearly payment, it is $1,358.69. I for interest rate, it is 6%. M for monthly, 1. T for time, it is 10 years. J, it is interest rate over periodic payment, it is 0.06. N equals 10 and K equals 4. So first, let us know what are the formula for prospective and retrospective method. For prospective method, here is the formula. BK equals R times 1 minus 1 plus J to the power of negative times N minus K all over J. For retrospective method, it is Bk equals P times 1 plus J to the power of K minus R times 1 plus J to the power of K minus 1 all over J. And now let us solve the problem using prospective method. Here is the formula. Bk equals R times 1 minus 1 plus J to the power of negative times N minus K all over J. Next, let us all substitute all the values. Bk equals, the R is 1,358.69 times 1 minus 1 plus J, which is 0.06 to the power of negative times N, which is 10, minus K, which is 4, all over J, which is 0.06. And lastly, let us all calculate all the values. So B4 equals $6,681.12. Therefore, the amount of the loan left right after the fourth loan payment is $6,681.12. And let us solve also the problem using retrospective method. The formula is Bk equals P times 1 plus J to the power of K minus R times 1 plus J to the power of K minus 1 over J. So let us substitute all the values. B4 equals P, which is $10,000 times 1 plus J, which is 0.06 to the power of K, which is 4, minus R, which is 1,358.69 times 1 plus J, which is 0.06 to the power of K, which is 4, minus 1 over J, which is 0.06. So let us calculate all the values. So the answer is B4 equals $6,681.02. Therefore, the amount of the loan left right after the fourth loan payment is $6,681.02 using the retrospective method.
Example number 3. Mr. and Mrs. Banal purchased a house and lot worth 4 million. They paid a down payment of 800,000 pesos. They plan to amortize the loan of 3,200,000 by paying monthly for 20 years. The interest rate is 12% convertible monthly. The question is, how much is the monthly payment? What is the total interest paid? And what are the principal and interest component of the 51st payment? Okay, so let's start with A. How much is the monthly payment? So the given for this problem is the principal or the P is equal to 3,200,000. The interest rate or I is equal to 12%. The Number of period per year or M is equal to 12. The time is equal to 20 years. The nominal rate or J is equal to 0.01. And the number of payment or N is equal to 48. So we need to find the R or the monthly payment. In order to find the monthly payment, we need to use the formula R is equal to P over 1 minus 1 plus J raised to the power of negative N over J, and then substitute the value. R is equal to 3,200,000 over 1 minus 1 plus 0.01 to the power of 2.40 over 0.01 is equal to 35,243.76. Therefore, the monthly payment is 35,243.76. So next is what is the total interest paid? So the given for this problem is the principal is equal to 3,200,000. The monthly payment or the R is equal to 35,243.76, and the N or the number of payments is equal to 240. So we need to find the total interest. In order to find the total interest, we need to find first the total payment. Total payment is equal to monthly payment times the number of payments. So the monthly payment is 35,243.76 times the number of payments, which is 240, is equal to 8,456,342.40. So after calculating the total payment, we will proceed to total interest. The total interest is the difference between the total payment, which is the 8,456,342.40, and the principal amount, which is 3,200,000. So 8,456,342.40 minus 3,200,000 is equal to 5,256,342.40. So therefore, the total interest is equal to 5,256,342.40. The last one is what are the principal and the interest components of the 51st payment. So the given is the principal is equal to 3,200,000. The monthly payment is 35,243.76. The interest rate is 12%. The period or the monthly period per year is 12. The time is 20 years. The nominal rate is 0.01 and the number of payments is 240. So to find the principal and interest components of the 51st payment, first we need to find the outstanding balance after the 50th payment using the formula B sub k is equal to R times 1 minus 1 plus j raised to the power of negative n minus k over j. And then substitute. So B sub 50 is equal to 35,243.76 times 1 minus 1 plus 0.01 raised to the power of negative 240 minus 50 over 0.01. And so therefore B sub 50 is equal to 2,991,477.63, and that is our outstanding balance after 50th payment. After calculating the outstanding balance after the 50th payment, we will now calculate the interest component by multiplying the outstanding balance after 50th payment and the nominal rate. So interest is equal to B sub 50, which is 2,991,477.63 times the nominal rate, which is 0.01. So that is 29,914.78. So our interest is equal to 29,914.78. Next, we will calculate the principal by subtracting the interest component of the 51st payment from the monthly payment. So our principal is equal to monthly payment, which is 35,234.76 minus the interest component, which is 29,914.78, is equal to 5,319.98. So therefore, for the 51st payment, The part that goes to pay the interest is 29,914.78 pesos, and the part that goes to pay the principal is 5,319.98 pesos.
So for our next topic is amortization. Amortization is a process of paying off a loan including interest by making a series of regular equal payments. The amortization method, in this method the borrower repays the lender by means of installment payments at periodic intervals. This process is called amortization of the loan. So to understand further about amortization, we will provide a series of examples. So example number 1. A fisherman purchases a new fishing boat for 15,000. He made a 3,000 down payment and financed the balance at his bank for 3 years. What amortization payment are required every 3 months at 10% interest to pay off the boat loan? So given A equals 15,000 minus 3,000 equals 12,000. J is equal for the interest rate. That would be 10%. M is equal to 4. Compounded quarterly. Time is equal to 3 years. I is equal to 0.025. Gikuha ni siya sa J over M. 10% over 4 equals to 0.025. N is equal to 12. Compounded quarterly 4 multiplied by time for 3 years. So, formula, R is equal to open bracket I times A over 1 minus open parenthesis 1 plus I close parenthesis powered by negative and close bracket. So that would be equal to R open bracket 0.025 times 12,000 over 1 minus open parenthesis 1 plus 0.025 powered by negative 12 close bracket. So, ang answer ana is 1,169.85. So, mao na siya ang required payment for every 3 months within 3 years. So, for the follow-up question, how much has the fisherman paid on the loan? And how much of that was the interest? So 1,169.85 times 4 for compounded quarterly times 3 for the time 3 years equals to 14,038.2. So mo to siya ang total payment of the fisherman, and how much of that was the interest? The interest is total payment minus the debt. 14,038.2 minus 12,000 equals 2,038.20. So example number 2, Adam purchased a motorcycle for 45,000 pesos with amortized monthly payments over 3 years at 9% interest. Find the amount of his payments. So given A equals 45,000, J equals 9%, M equals 12 for compounded monthly, T equals 3 years, I equals 0.0075, and equals 36. So using the same formula, that would be R equals 0.0075 times 45,000 over 1 minus open parenthesis 1 plus 0.0075 with the power of negative 36. That would be equal to 1,430.99. So, mo na siya ang monthly payment ni Adam within 3 years with 9% of interest rate. So, follow-up question, how much will Adam pay and how much of that was the interest? So, 1,430.99 times 12 times 3 equals 51,515.64. So, mo ni siya ang total payment ni Adam. And how much of that are the interest? So, total payment minus debt, 51,515.64 minus 45,000 is equal to 6,515.64. So, mo na siya ang total interest ni Adam within 3 years with 9% interest.
The problem is, a debt of $10,000 is amortized by making equal payments at the end of every 6 months for 3 years, and the interest is 6% compounded semi-annually. So for the solution, step 1, we need to determine first the payment value. So to determine the payment value, first we calculate the value of the payments using known methods, such as the formula for a general ordinary annuity. So as you can see here, this is the formula of ordinary annuity. So the formula that we're going to use to get the PMT is P over 1 plus J to the power of negative K minus 1 over J, where P is the principal value, which is the $10,000, over 1 plus 0.03, which is the interest rate per annum divided by the number of period per year, times to the power of negative 6 minus 1 over 0.03. So to calculate this, we get the periodic payment amount, which is the 1,845.98. For the next step, we have here the constructed table of amortization schedule. So as you can see in the first column, it shows the payment period or the period number. The next column is periodic payment, which is the size of each periodic payment amount. Next column is the interest that is included in that payment. Next is the principal repaid in that payment period. And last is the outstanding or remaining principal balance after each payment. And then we have here at the beginning period 0, we only have the $10,000 loan as the outstanding principal balance. So since we have 6 annual payments to pay off the loan, I drag down the period until 6. So for the next step, we need to calculate the missing information in each row using the steps below. So step 1, calculate the interest component of the payment. So interest paid equals the J, which is the 0.03, times the outstanding balance, which is the $10,000, to get the interest paid, which is the 300. And then the next step, we need to calculate the principal paid by subtracting the interest paid from the payment amount. So principal repaid equals the payment amount minus the interest paid. So the payment amount is 1,845.98 minus the interest paid, which is the 300, to get the answer of 1,545.02. And then repeat the same process using the same formula until the period of 6 to get the payment of each period. And then the last step is to adjust the payment. So in our last example, the following changes are made in the past payment now. So we already have our value. So now let's proceed to sum the totals of periodic payment, the interest, principal repaid, and outstanding balance. So now we have the total of periodic payment here, which is 11,056.86. And then the interest is 1,056.86. And then the principal repaid is 10,000. So the analysis in this problem, in this scenario, a $10,000 debt is being amortized over 3 years with equal payments made every 6 months. The interest rate is 6% compounded semi-annually. To understand the repayment process, we need to construct an amortization schedule which will outline how each payment is allocated between interest and principal. That is leading to the gradual reduction of the debt over the specified period.
Sinking funds. A sinking fund is a fund that includes funds set aside or borrowed to pay off a loan or debt. The sinking funds method. In this method, the borrower will repay the lender by means of one lump sum payment at the end of the term loan. In sinking fund is managed by arranging a side fund over a span of time to meet prospective future expenses. No? Like for example, in a classroom scenario where students collect a bit of money each week to save up for a fun class activity, so ensuring they have enough when it's time for the event. So that is an example of sinking funds. So these are the formulas for sinking funds. So D equals C sub O minus C sub N times I over 1 plus I to the power of N, then minus 1. And next is D equals C sub O minus C sub capital L times I over 1 plus I to the power of L, and then minus 1. And for the book value at the end of nth years, C sub N is equals to C sub O minus D sub N. And for the depreciation at the end of nth years, so it is D sub N is equals to D times 1 plus I to the power of L minus 1, and then over I. So here are the terminologies used in computing depreciation. So first, C sub O, original cost of the property. C sub N, book value or the appraisal value or the value of the property at the end of nth year. Then C sub capital L, the salvage value or the value of the property at the end of the useful life. Then the small d, uniform annual depreciation, and small d sub N, depreciation charged during the nth year. Then capital D sub N is the total depreciation up to the nth year. Then capital D sub capital L is the total depreciation charged throughout the entire life of the property. And capital L is the useful life of the property in years. And lastly, I is the interest rate per year. So example number 1. A dump truck was bought 30,000 pesos 6 years ago, and it will have a salvage value of 3,000 pesos 4 years from now. It is sold now for 8,000 pesos. What is its sunk cost, or a cost that can be recovered due to certain reason, if the depreciation used in a sinking fund method at 6%? So here are the given. C sub O is equals to 30,000, or the original cost of the property. L is 10 years, so I just add the number of years mentioned in this problem. And I is equals to 6%, and C sub L is equals to 3,000, or the salvage value, and C sub 6 is 8,000. As mentioned in this problem, that it is sold for 8,000. And then C sub N is missing. So for the solution, first we're gonna use the formula D equals C sub O minus C sub L times I over 1 plus I to the power of L minus 1. So just plug in D equals 30,000, or the original cost of the property, minus 3,000, or the salvage value, times 0.06 our rate, then over 1 plus 0.06 to the power of 10 over L, then minus 1, and the result will be 2,048 pesos 0.43 centavos. The next step is to use the formula D sub N is equals to D times 1 plus I to the power of N, and then minus 1 over I. So just plug in the total amount of D in this formula. So D sub 6 is equals to 2,048 pesos 0.43. So then multiply by 1 plus 0.06 our rate to the power of 6. Our N here is 6, and then minus 1 over 1 over 0.06. and the result will be 14,288 pesos, 0.49 centavos. And the last step is to use the formula C sub n is equals to C sub O minus D sub n. So just plug in 30,000 minus 14,288 pesos 0.49, but we also have to include the C sub 6 here, which is the 8,000. So we're gonna minus it to the value, and the result will be 7,711.5. So that's it for the example number 1.
So here is the problem. A unit welding machine costs 45,000 pesos with an estimated life of 5 years. Its salvage value is 2,500 pesos. Find its depreciation using sinking fund method at 8.5%. But first, let us know what are the given. CO, or the original cost of the property, it is 45,000 pesos. L, the useful life of the property in years, which is 5 years. I, the interest rate, it is 8.5%. CL, which is the salvage value of the property, which is 2,500 pesos. And we will find the depreciation. So here is the solution. Using the formula, D equals CO, which is the original cost of the property, minus CL, which is the salvage value of the property, times I, which is the interest rate, all over 1, plus I, which is the interest rate, to the power of L, which is the useful life of the property in years, minus 1. Then, let us all substitute all the values. The original cost is 45,000 minus the salvage value 2,500 times the interest rate 0.085 all over 1 plus the interest rate 0.085 to the power of L, which is the useful life of the property, which is 5 minus 1. And lastly, let us all calculate all the values. So the answer is 7,172.54 pesos. So the depreciation amount is 7,172.54 pesos, and this is the amount that you will pay a period of 5 years.
Example number 3. An equipment cost 100,000 pesos with a salvage value of 5,000 at the end of 10 years. Compute the annual depreciation cost using sinking fund method with interest rate of 4%. So the given for this problem is C sub 0 is equal to 1,000 pesos, the L is equal to 10 years, the I is equal to 4%, the C sub L is equal to 5,000, and D is missing. So we need to find the D by using the formula D is equal to C sub 0 minus C sub L times I over 1 plus I raised to the power of L minus 1. Substitute the value. P is equal to 100,000 minus 5,000 times 0.04 over 1 plus 0.04 raised to the power of 10 minus 1. So D is equal to 7,912.64.
So, this is the generalization of amortization and sinking funds method. So, both sinking fund and amortization can be used to pay off a debt, but they differ in their approach and purpose. The primary purpose of a sinking fund is to ensure that there is enough money available to meet the future financial obligations. Amortization, on behalf, is a method of paying off a debt over a period of time. It involves making regular payments that include both principal and interest. The principal portion of the payment reduces the outstanding balance of the debt, while the interest portion represents the cost of the borrowing. While both have their pros and cons, and the best option depends on individual financial goals and circumstances. It's important to have a clear understanding of these concepts in order to make informed financial decisions.